This video is going to teach you about atomic theory. Atoms are the basic building blocks of all matter that make up everyday objects. Atoms are made up of a nucleus and an electron cloud. Atoms are the smallest particles of an element that keep the same properties of that element. Atoms are also very small. To give you an idea of how small atoms are, look at this number here. This number with all those zeros is how many atoms would be in just one penny. There are 3 subatomic particles that are part of an atom. Those particles are electrons, which have a -1 charge, a mass of almost 0 because they're so small and they're located in the electron cloud. The other particles are protons and neutrons. Protons have a +1 charge. They have a mass of 1 atomic mass unit, and they're located in the nucleus. Neutrons have a charge of 0. They're neutral. They have a mass of 1 atomic mass unit, and they're also located in the nucleus. The negative particles in atoms are called electrons. They're also sometimes called cathode rays. They were discovered by a scientist named J.J. Thomson, and electrons are the basics of what makes things like your television work. The positively charged particles in atoms are called protons. Protons were discovered by Ernest Rutherford in his famous gold foil experiment. Protons are found in the nucleus. The neutral particle in an atom that has no charge is called the neutron. Neutrons were discovered by James Chadwick, and they are also found in the nucleus. So like we said earlier, atoms are made up of a nucleus, which is the tiny dense region in the middle, and an electron cloud, which is this big region that's around the nucleus. Atoms are mostly made up of this empty space out here in the electron cloud. But all of the mass is located here in the nucleus in the middle. The number of protons in an atom is also called the atomic number. The atomic number identifies the element, and all atoms of an element will always have the same number of protons. Using a periodic table, you should be able to identify the atomic number and the number of protons in each of these elements. So take a minute, get a periodic table, and see if you can fill out this chart below. And once you've got it, you can check your answers with these. Right, here's a little learning check question for you. It says a certain atom has a nucleus containing 6 protons and 8 neutrons and has 6 electrons orbiting the nucleus. This atom is a form of the element what? So you look on your periodic table and figure out which element has 6 protons, which one has the atomic number of 6, and if you take a look, 6 is carbon, which is answer B. Now take a minute and check to see if you can figure out the number of protons in each of these elements. And check to make sure you got the same answers as me. Here's another question you might see where you have to identify what element from a picture. So here, if you look at this picture, we can identify what element it is by looking at the number of protons, because that'll tell us the atomic number. We know protons are positive, so we've got 1 proton here, 1 here, 1 here, 1 there. So that's a total of 4 protons. So now we look for the element with the atomic number of 4, which would be Be or beryllium. The mass number is another important number for you to know. The mass number is the number of protons plus the number of neutrons that are in an atom. Another thing you see on the periodic table is the atomic symbol, or the abbreviation for elements. So in an atomic symbol, what you will see is you'll see the abbreviated element name, so Na is for sodium. You'll see the mass number, so for sodium that would be 23, and you'll see the atomic number, which is 11 for sodium. This is the way you would usually see the atomic number, the symbol, and the atomic mass on a periodic table. One way to tell the difference, if you're getting confused between the atomic number and the atomic mass, the atomic number will always be less and it'll always be a whole number. The atomic mass will be more and it may have a decimal. That's because it's an average of the masses of all the isotopes. So here's an example of the atomic symbol for carbon, and you may see this word atomic weight. Just know that means the same thing as atomic mass. Don't let that mess you up. Take a look at this chart in a periodic table and see if you can figure out the mass number, the proton number, and the neutron number for each of these elements, and also fill in the elements that are missing from the chart. And once you've looked at it, check your answers to make sure you got the same things as here. So you may be wondering why the mass number that's on the periodic table is a number with a decimal instead of a whole number. So like I said before, that mass number is telling you the average mass of all the different isotopes of that element. So now we got to know what are isotopes. So isotopes are basically atoms of the same element, meaning they have the same atomic number, the same number of protons, but they have different mass numbers. So they have different numbers of neutrons. An element can have different numbers of neutrons, but an element can't have different numbers of protons because the number of protons is what makes it that element. So for example, you could look at isotopes of chlorine. So here you could have an isotope of chlorine that we'd call chlorine 35 that has 17 protons and 18 neutrons, giving it a mass number of 35. Or we could have chlorine 37 that still has 17 protons because it's still chlorine, but now it has 20 neutrons, giving it a mass number of 37. Take a look at this example and see if you can figure out the number of protons, neutrons, and electrons in each of these carbon atoms. And to give you a little hint, the number of electrons is going to be the same as the number of protons unless it's a charged element, which none of these are. So if we look at the answers for this one, the first one has 6 protons, 6 neutrons, and 6 electrons. The second one, carbon 13, has 6 protons, 7 neutrons, and 6 electrons. And carbon 14, the third one, has still 6 protons, now 8 neutrons, and 6 electrons. And here's a little image of what you could think about those carbon atoms looking like with the different numbers of neutrons, same number of protons. And lastly, here's an example of how the atomic mass that you see on the periodic table would be calculated. So you can see an example over here of how you would calculate that average atomic mass using the masses of the different isotopes. So basically what you do is you take each isotope and the percent abundance, which is shown here as the percent. That just means however many or what percent of the magnesiums that exist are that certain isotope. You take that for each one of the isotopes, you take that information. So this is saying 78.99% of the magnesiums in the world are magnesium-24, which has a weight of 23.985 AMUs, atomic mass units. 10% of the magnesiums in the world are magnesium-25, which have this mass. 11.01% are magnesium-26 that have this mass. So you take that information and you're going to get the weighted average by multiplying the percent times the mass, getting your answer here. And you do that for each one, multiply the percent times the mass, get your answer, percent times the mass and the answer, and then once you have those 3 or however many isotopes there are calculated, you add them all together, and after you add those, you get the total, which is the weighted average atomic mass. And that's what you see on the periodic table.